All right, here's a video to take you through your practice test and go through each problem step by step. So, which of the following, we should start with our goal. I can perform operations with complex numbers. So remember, complex numbers are written in the form a plus bi, where a is real, and the I stands for the imaginary square root of -1. Which of the following is a way to write this as a complex number in standard form? Well, this says to multiply. So 4 times 3 is 12. Plus 4 times -5 is minus 20i. Minus 6i plus 10i squared. So I'm going to start combining my like terms. 12 minus 26i plus 10i squared, but this isn't in standard form. Standard form would be to take that I squared, and remember that that becomes -1. So really I have 12 minus 26i plus 10 times -1, which is 12 minus 26i minus 10, or 2 minus 26i. I believe I'm in 2019 one, it's answer choice E, but this is going to be answer choice D. All right, what is the value of I? Well, the square root of 1 is just 1, so that's defined for us. 1 is just 1. -1 is just 1. This is the thing that is new to us. We don't have a way to mathematically define it, so we instead call this I. Consider these two complex numbers. What do you get when you subtract? Well, to subtract, I first need to distribute this negative sign. So 3 minus 3i minus 1 plus 6i. I'm going to combine my real parts, 3 minus 1, which is 2. I'm going to combine my imaginary parts, -3 plus 6i is 3i. All right, when we multiply, just like the first question, 3 times 1 is 3, plus 3 times -6 is a -18i, minus 3i plus 18i squared. I'm going to clean up what I can. And then notice that 18i squared, that I squared becomes a -1. So really what I have is 3 minus 21i. 18 times -1 gives me -18. Now combine my real parts. 3 minus 18 is -15. And my imaginary part, which is -21i. All right, that's your page all about complex numbers. Next goal. I can use the technique of completing the square to solve problems involving quadratic equations. So first one says complete the square, then identify the vertex, so HK, of this quadratic function. Well, to start completing the square, I always start by moving my C value to the other side. Then I take half of my B value. So 4 divided by 2 is 2. Square that becomes 4. So I'm going to add 4 to both sides. On this side, I get y plus 9. And on this side, I'm going to factor that down into x plus 2 squared. Because if I expanded that out, I would end up with that trinomial listed above it. And then I'm not solving, I'm looking to write this in vertex form. So I'm going to get y by itself. Now if I think back to previous math, so unit 2, this graph has been shifted to the left 2 and down 9, which means the vertex has been shifted to the left 2 and down 9. Next one, solve using completing the square. So the process is the same, except this time, instead of getting y by itself for vertex form, I'm actually looking to solve for x, because this whole thing is set equal to 0. So I'm going to start, as always, by moving that c value over. I get x squared plus 14x equals 11. Take that b value, divide it by 2. Divide it by 2. Which is 7, square it, which is 49. So I'm going to add 49 on this side. And I'm going to add 49 on this side. Over here, I'm going to get x plus 7 squared. And on this side, I'm going to get negative 11 plus 49, which is going to end me with, oh my goodness, that should be a plus 11. My apologies. And I get 11 plus 49, which ends me with 60. Taking the square root of both sides, I get x plus 7 equals plus or minus 60. And then I'm going to add the 7, well, subtract the 7 to the other side. So minus 7 plus or minus the square root of 60. The last thing I need to do, it says to simplify my answers. So the square root of 60 can be broken down in the square root of 4 and the square root of 15. So really, my x answers are negative 7 plus and minus 2 root 15, because the square root of 4 is 2. Rewriting them as ordered pairs, I'm just going to break the plus minus apart. X-intercept. And another x-intercept. Those are my two answers. All right, rewrite in vertex form, then identify the vertex. So f of x is really just the same thing as y. So I'm going to start by adding my constant to the other side. I'm then going to take half of my b term and square it. Add that value to both sides. Eek, squish it in there. This side gets broken down into x plus 4 squared. This side is going to be f of x plus 27. Well, vertex form then, I need to get my y value by itself. So here's my vertex form. The ordered pair then of the vertex is going to be shifted left 4 and down 27. So there's your HK, or your vertex. All right, I can use the quadratic formula to establish connections between the quadratic function and its graph. So solve the following equation and then identify what that tells you about the function. You could try to factor this one. It's not going to factor. You could try to complete the square, but when you divide the 3 by 2, you're going to get some messy fractions. This is on the quadratic formula page, so it's probably a good idea to use the quadratic formula. So identifying my A, B, and C is where I want to start. A equals 1, B equals 3, C equals negative 1. Singing the song to in my head to myself, X equals opposite B plus or minus square root B squared minus 4AC all divided by 2A. Okay, well, X equals negative 3 plus or minus, when you put this in your calculator, you get 13 all over 2. 13 does not have any perfect squares in it to break down. All right, there's nothing we can do, so it just stays as the square root of 13. So we get x equals negative 3 plus root 13 over 2, and x equals negative 3 minus root 13 over 2. Because we have two real answers, no imaginaries going on, we are going to cross our x-axis twice. Find the value of the discriminant. Well, the discriminant is b squared minus 4ac. It's the part that's underneath the square root in the quadratic formula. Might want to make sure that's on your summary sheet. So again, it helps to identify a is 6, b is 4, and c is 3, which means that b squared is going to be 16 minus 4 times 6 times 3. gets us a final discriminant of negative 56. Well, if we have a discriminant that is negative, if you look back at your notes, a negative discriminant tells us that we have two imaginary solutions because we would be taking the square root of a negative 56, which will have an I in our final answer. And what that means about the x-intercepts is that we don't ever cross the x-axis. So this would be one of the parabolas that's floating completely above. Okay, it's never going to cross over the x-axis because of that imaginary, the imaginary roots coming from the negative discriminant. All right, 3.4 goal, I can solve nonlinear systems of equations. So what makes this nonlinear is going to be the fact that we have an x squared here. So to start, I'm going to get each of these equations just set equal to y. So I'm going to move this 5 to the other side. So minus 5, minus 5. And I'm going to add y to the other side. Okay, so really I'm just getting y by itself. Y equals x squared plus 2x minus 5. Okay, you can take a second to shuffle those variables around so that they match this order if you're trying to follow with the video. This one, to get y by itself, I just need to subtract 2x to the other side. Okay, so now you could stack these on top of each other and use elimination, but we've been working with the substitution method. Both of these y's are equal, which means that this green expression is equal to this blue expression. Next thing then, we want to get this into standard form. And we want to factor things that multiply to negative 12 and add to 4 are going to be something with 6 and 2. Because this was positive, this becomes positive, the bigger number, and then this gets minus. So we get x equals 2 and x equals negative 6. So what that means is my solution points are 2 comma something and negative 6 comma something. And that something I'm missing is the y value. Well, I think the easiest place that I have y is right here. Y equals 7 minus 2x. So if I plug in this 2, I get y equals 7 minus 2 times 2. And if I plug in this negative 6, I get y equals 7 minus 2 times negative 6. So this one's going to end up being 3, and this blue one ends up being 19. So what this is saying is your parabola and your line are going to intersect twice.